Well, this video is all about the kind of question that you typically get in the IB on-screen exam that involves a table of values, some kind of a function involving two variables, n and p in this case, and a rule that links them. And what you're often asked to do is fill in a table of values, maybe make some predictions for further values than the ones that they've given you, and make a rule that links the two things. So in this table I've got n and p. I've just randomly named them with those letters, no particular meaning behind that. And I've made a little function machine where you put the n number in and it gives you the p number out. And we're going to try and figure out a rule. So when n equals 1, p equals 11. Let's see what happens when n equals 2. So 2, enter. And then when n equals 2, p equals 16. Okay, well I guess we need to try and find it for 3 to see a pattern. So when n equals 3, press enter, and we get 21 out. And I'm starting to notice that these are going up by 5 every time. So I should expect the next one to be 26. Let's try that. So when n equals 4, p equals 26. So I'm noticing that each number is the previous one plus 5, but that's not a very useful rule, because if we want the 1000th number, we don't really want to have to work out the previous 999. But there are clues here that can help us to get a rule that takes us directly from the n number to any p number without having to figure out every term in the sequence. So first of all, the fact that these go up by 5 every time these go up by 1 gives us a clue that the rule for p must at some point involve taking the n number and multiplying it by 5. So 5n. But if the rule was just 5n, then 1 times 5 would be 5, and 2 times 5 would be 10, and 3 times 5 would be 15, and 4 times 5 would be 20. So we'd get a sequence of numbers that does indeed go up by 5 every time, but it's not the sequence of numbers we're looking for, because we're looking for 11, 16, 21, 26. But there is a direct link between these two sequences, because if we take this row here with the 5, 10, 15, 20, and then just add 6 to everything, we'll get the 11, 16, 21, 26. So for that reason, the rule looks like it's 5n plus 6, and then you get 11 and indeed 16 and indeed 21 and indeed 26. And then we ought to be able to make a prediction for the next one. So if the rule is 5n plus 6, then the next one should be 5 times 5, which is 25, plus an extra 6 makes 31. So if my rule is correct, I should be able to put 5 in and get 31 out. So let's try that. n equals 5, and we do indeed get 31 out. So my rule is that p equals 5n plus 6. So this is a spreadsheet that I've made myself, and I'm making it available to my MYP5, so you will get a link to this. And if you go a bit further down, you've got all of the bits that make it work. So down here I've got my rule, p equals 5n plus 6. And what you can do is change the rule to something else. So p equals, let's say, 8n, we can make it a minus 3, like that, and it'll change the rule to 8n minus 3. And then up here it will generate different numbers for whatever you put in. So what you can do in pairs in the class is one of you make up a rule, and then the other one, using a strategy like the one I just described, try and work out that rule. So that's a simple linear rule where something equals something times something else, then plus or minus a number. in this spreadsheet I've got various tabs with different levels of difficulty. So on the second tab of this spreadsheet I've got a more complicated rule that generates a number, this time I'm calling it L, from two different variable values. I've called them A and B. So when A equals 1 and B equals 1, L comes out to be 17. Let's see what difference it makes if A equals 2. Okay, so if A equals 2 and B equals 1, we get 22. Let's see what happens when A equals 3. Then we get 27, so when A equals 3 and B equals 1, we get 27. So it looks like making A go up by 1 makes L go up by 5. So I would expect the next one, 4 and 1 there, to be 32. Let's see if that works. 4 and 1, we do get 32. So if making A go up by 1 makes the L go up by 5, that gives us a little bit of a clue that the rule might involve something with 5 times A. Let's see what happens when we change B. So when A equals 4 and B equals 2, L is 38. When A equals 4 and B equals 3, L is 44. So it looks like making B go up by 1 is making the L go up by 6. So if that's true, then we should expect the next one with 4 and 4 to be 50. So let's make that prediction. And indeed it is 50. So it looks like the rule involves something like 5A plus 6B. But if that is the rule, then if it's just 5 times the A plus 6 times the B, let's see what we get. I can actually put a formula in here and say that that cell here equals 5 times that one plus 6 times that one. Obviously I can't do that in the exam, but we're not in the exam now. So, and then I can copy that formula across. So if the rule is 5A plus 6B, well, we seem to get a related sequence of numbers, but not the same sequence of numbers. So the sequence of numbers we're getting here seems to be always 6 less than the numbers we want to get. So if we take 5A plus 6B and then add 6 to it, then that should give us a rule that works. Let's just resize that. So these numbers are just going to be these numbers plus an extra 6 equals that plus 6. And then we're getting the numbers that we want to get. So I predict that my rule is L equals 5A plus 6B plus 6. Well, I can test that. So if that is indeed the case, I ought to be able to pick something outrageous like 85 and 17 for B, and then I predict that the value of the function that I get is 533. So let's put it into the function machine and see if that works. 85 and 17, and we do indeed get 533. So again, this is a spreadsheet you can play with. You can go a bit further down, get someone to change the rule, and then try and work out using a similar line of reasoning what their rule is. So it can be numbers like 5, it could be something like 2/3. So you put it in like 2/3 like that, and it doesn't like that because it thinks that's text, but let's put equals 2 over 3, then it'll recognize it as a number, and that kind of works as 2 over 3. So you can put in things like fractions or minus numbers, -3, all sorts of things. Don't make it too ridiculous, but there was an exam question once where it was something like 1/3 of something plus 2/3 of something else.